Hi, my name is Casey Haydari, and I'm a Senior Manager of Finite Element Development at MSC Software Corporation. Today, we will be presenting a unique industry standard solution from MSC Software for efficiently performing accurate fan blade out and bird stroke simulations on jet engines. Bird stroke and fan blade out are very complex analyses. They involve these three stages. 1. Pre-stress analysis. This is done in order to capture the residual stresses and deformation of fan blades due to high rotational velocities. 2. The bird stroke and/or fan blade out analysis. This is a transient dynamic simulation of the bird stroke or the fan blade out analysis, or both. A typical fan blade out engine model can easily exceed 3 to 4 million finite elements. Also today, a fan blade out event can be extremely nonlinear because of the heavy wide chord fan blades incorporated in the new generation of high bypass ratio jet engines. 3. Rotor dynamics. When one or more of the fan blades are broken after the bird impact or fan blade out is performed, the fan blades are no longer axisymmetric due to the missing blades or severe fan blade deformations. As a result, the engine experiences out of balance forces and starts spinning out of its longitudinal axis. The fan blades also start hitting the inner walls of the containment structure, creating different loads such as impact and rubbing loads. If the rub loads are large enough, they can potentially result in a seizure torque that can stall the engine and cause fusing. Fusing is when the engine's main rotor shaft bends and breaks the bearings that are located on various locations of the shaft. These loads are extremely important for manufacturers since they will influence the safety of the aircraft and its navigation capacity. The pre-stress and rotor dynamics are both long duration events, usually lasting a few seconds. This is in contrast to fan blade out or bird strike, which are both short duration events and usually take only a few milliseconds. These differences among the stages call for different finite element technologies and solvers to be used in order to simulate these events. Specifically for the pre-stress analysis of the blades and rotor dynamics analysis, implicit solvers are needed, whereas to simulate the fan blade out event, an explicit solver is required. Moreover, the way this is done today also presents other certain inefficiencies and challenges. Since the engine models between airframe and engine manufacturers are not shared, either due to trade secrets, sensitive nature of the design, or liability issues, engine manufacturers traditionally will send only the loads that are generated from a fan blade out or bird stroke analysis to the airframe companies. Next, the airframe manufacturer will recreate the engine model for rotor dynamics. The rotor dynamics model is much simpler than a fan blade out engine model and will typically consist of less than 50,000 elements compared to the 3 to 4 million elements of a fan blade out model. As a result, they miss out on applying the millions of impact and rub loads that were generated from a bird strike or fan blade out analysis to the right location of a much coarser mesh of the rotor dynamics model at the right time. Because of this, they end up with lower fidelity analysis results and potentially an inaccurate assessment of the fan blade out and rotor dynamics events. MSC Software has resolved this issue by providing the ability to chain all these events in one modeling software. MSC Nastran leverages its implicit and explicit solutions. It uses its Solution 700 implicit solver for pre-stress analysis. Then, it uses Solution 700 explicit solver for the fan blade out or bird stroke event, and finally, Solution 400 for the rotor dynamic simulation. This methodology allows the engine manufacturers to use MSC Nastran Solution 700 explicit solver to save the realistic loads, which could be in millions, in a Nastran database, maintaining the necessary fidelity without exposing the confidential model information and IP copyrights. Those loads are then passed on to the airframe companies in Nastran database format. The airframe companies then use MSC Nastran Solution 400 implicit solver to read in the loads onto the rotor dynamics model, which is much coarser than the fan blade out engine model. Solution 400 has an advanced searching and mapping algorithm that will read in the transient loads from the fan blade out analysis and apply them on the new rotor dynamics model in the exact location at the exact time. By using MD Nastran, the aviation industry has not only eliminated approximations and guesswork that could result in poor designs and high costs, but have also significantly reduced the design cycle of the product by using a common environment under MD Nastran. In addition, for bird strikes, the bird can be modeled as a fluid by using the advanced Eulerian technology that also exists in MD Nastran. A fluid bird can accurately capture the physics better than a Lagrangian model bird, especially when the trailing blades are hitting the bird and slice it like salami. These CPU-intensive simulations can be dramatically reduced by leveraging the advanced distributed memory parallel technology available in Nastran. Thanks for watching. If you'd like to learn more about how MD Nastran can help you get the results that you've been looking for your complex simulation events like the ones discussed here, please go to mscsoftware.com.